As we know, energy can be transformed from one form to another. For example, the fan receives electric energy. This electric energy will be transformed by the fan motor into mechanical energy and heat energy as well. Mechanical energy is said to be useful produced energy, while heat energy is lost energy. Let's take another example, the lamp. It receives electric energy, transforms it into useful light energy, and lost heat energy. Note that the flow of electric current in any conductor is accompanied by the liberation of heat. The transformation of electric energy into heat is called Joules effect. Joules effect is made use of in such devices such as radiator, iron, hairdryer. The heat liberated in this case is useful, in which our aim is to obtain heat. However, Joules effect could be a disadvantage in other cases, such as in the case of a computer, radio, electric motor, in which the heat dissipated is useless, which means that the heat liberated is a loss. Let's recall the two physical values related to electricity that we have taken in the previous sessions: electric power and electric energy. Now we want to find out how do we calculate electric power and electric energy of a resistor. As we know, resistor is an electric component used to regulate the flow of electric current in electric circuits. It uses up electric energy and dissipates it as heat. The power and energy consumed by a resistor are converted completely into heat. This conversion is known as Joules effect. Let's express the power in a resistor in terms of resistance R and current I. Starting with a rule, power equal UI. As we know that the voltage across a resistor is equal to Ri. By substitution, we substitute U by Ri, so the formula will be power equals Ri times I, which means power is equal to Ri squared. So the power in a resistor is equal to Ri squared. R resistance in ohms, I current in ampere, and P power in watt. Let's solve this application. Given a resistor of resistance R 100 ohms, the current carried by this resistor is 2 ampere. Calculate the power consumed by this resistor. Think about it, then check the answer. Using the rule, power equals Ri squared, resistance is equal to 100 ohm, current is equal to 2 ampere, so 100 times 2 to the power of 2 is equal to 400 watt. The power consumed by this resistor is 400 watt. Solve this application, then check your answer. Here we have to calculate the current carried by the resistor. Power equals Ri squared. To calculate I squared, we have to divide power by resistance. So 40 watt divided by 1000 ohms, 0.04 ampere is the answer. The value obtained is I squared and not I. To get the value of I, we have to find the radical of 0.04, which is equal to 0.2. So 0.2 ampere is the current carried by the resistor. Now let's express the energy in a resistor in terms of resistance, current, and time. Try to find out the answer the same way we have done in the case of power in a resistor, then continue watching to know the answer. Starting with a rule, energy is equal to power multiplied by time. Here, the time is already expressed in this rule. Still have to think about how to substitute the power using terms resistance and current. As we have learned previously in this session, that power in a resistor is equal to Ri squared. So by substitution, I will substitute the power by Ri squared. The energy in a resistor will be equal to resistance multiplied by current squared multiplied by time. R resistance in ohms, I current in ampere, T time in seconds, and E energy in joules. Solve this application, then check your answer. Calculate the amount of heat in joules dissipated by the resistor during 10 minutes. Using the formula E equals Ri squared T, resistance is given 100 ohms, current is equal to 2 ampere, time is given 10 minutes. Here we have to pay attention to the SI units. The time should be in seconds instead of minutes. So we have to multiply 10 minutes times 60 to get the answer in seconds, which is equal to 600 seconds. So 100 times 2 squared times 600 is equal to 240,000 joules. So the heat dissipated by this resistor in 10 minutes is equal to 240,000 joules.